Today we are going to learn about efficient data manipulation with Numpy indexing. We will explore advanced techniques for slicing, boolean indexing, and fancy indexing to manipulate data efficiently.
Welcome to this course on efficient data manipulation with Numpy indexing. In this introductory session, we will set the stage for our journey into the world of data manipulation using Numpy. Understanding how to index and slice arrays is foundational in data science. Indexing allows us to access and modify specific parts of our data, which is crucial for analysis and transformation tasks. Today, we'll delve into slicing basics, learn about boolean indexing for conditional data selection, and explore fancy indexing for accessing multiple array elements. By the end of this course, you'll have a toolkit of skills to handle complex data scenarios efficiently. Let's begin by understanding the basics of Numpy array indexing and slicing. Numpy arrays are the building blocks of data manipulation in Python, and they can be one-dimensional or multidimensional. Grasping the concept of array dimensions is crucial. Slicing involves selecting portions of an array using a start, stop, and step approach. For instance, array start-stop step is a common slicing pattern. You can access subarrays by specifying these indices, allowing for flexible data manipulation. Additionally, Numpy supports the use of negative indices, which count from the end of the array, offering greater flexibility in data selection. Let's go through practical examples to solidify these concepts.
Next, we'll explore boolean indexing, a powerful technique for selecting data based on conditions. Boolean indexing involves creating a Boolean array, where each element is true or false, based on a condition applied to the original array. This Boolean array can then be used to filter the data, selecting only those elements that satisfy the condition. For example, you might use a condition like array greater than 5 to create a Boolean array, and then index the original array to extract elements greater than 5. You can also combine multiple conditions using logical operators like and for and vertical bar for or to refine your selection criteria. Let's examine examples that illustrate the creation and use of Boolean arrays for efficient data filtering.
Fancy indexing is another advanced technique that allows you to access multiple array elements simultaneously using integer arrays as indices. Unlike regular slicing, which retrieves contiguous slices of an array, fancy indexing lets you select elements in any order you choose. This is particularly useful when you need to extract non-sequential elements from an array. Fancy indexing is efficient because it allows direct access to the desired elements without the need for loops. For instance, if you have an array and want to select elements at positions 1, 3, 5, you can simply pass this list of indices to the array. Let's dive into practical applications and examples to see how fancy indexing can streamline complex data selection tasks.
In this section, we'll explore how combining different indexing techniques can enhance your data manipulation capabilities. By merging slicing, Boolean indexing, and fancy indexing, you can create highly customized data selection strategies. For example, you might use slicing to select a subset of your array, then apply Boolean indexing to filter elements based on a condition, and finally utilize fancy indexing to reorder or select specific elements. This layered approach allows for efficient and flexible data manipulation, enabling you to tackle complex data scenarios with ease. Through detailed examples, we'll demonstrate how these combined techniques can be applied to real-world data challenges, showcasing their power and versatility.
While Numpy indexing is a powerful tool, it's not without its challenges. In this block, we'll discuss common pitfalls and best practices to ensure your indexing operations are efficient and error-free. One frequent mistake is misunderstanding array shapes, which can lead to indexing errors. It's crucial to be aware of the dimensions of your arrays and how they affect indexing operations. Another common issue is attempting to index beyond the array's limits, which can result in errors. We'll provide tips on avoiding these mistakes, including techniques for verifying array shapes and dimensions before indexing. Additionally, we'll share best practices for reliable indexing and strategies for debugging common issues, ensuring your data manipulation workflows are smooth and efficient. Understanding the performance implications of different indexing methods is crucial for optimizing your data manipulation workflows. In this section, we'll compare the performance of slicing, Boolean indexing, and fancy indexing to understand their impact on computational efficiency. While slicing is generally the fastest due to its simplicity and contiguous data access, Boolean and fancy indexing offer flexibility at a potential cost to speed. We'll explore strategies for optimizing data access speed, balancing the need for readability and maintainability with performance considerations. We'll also examine case studies where indexing performance plays a critical role in data-intensive applications, illustrating how to choose the most efficient method for specific scenarios. By the end of this section, you'll have a clear understanding of how to make informed decisions about indexing based on performance requirements. To solidify our understanding of Numpy indexing, let's explore real-life examples of data manipulation using these techniques. Indexing is a cornerstone of data science workflows, and its applications are vast. We'll examine case studies where indexing plays a pivotal role in data cleaning, transformation, and analysis. For instance, we'll look at how boolean indexing can be used to filter outliers or missing values from a dataset, and how fancy indexing can be employed to reorder and organize data for analysis. Through practical examples and demonstrations, we'll see how indexing techniques can be applied to complex datasets, solving real-world data challenges efficiently and effectively.
Despite its power, Numpy indexing can sometimes lead to errors or unexpected results. In this block, we'll focus on troubleshooting common indexing issues to ensure your data manipulation tasks proceed smoothly. One common problem is array shape mismatches, which can arise when attempting to index arrays of different dimensions. We'll explore strategies for identifying and resolving these mismatches, including techniques for verifying array shapes and dimensions before indexing. Additionally, we'll discuss how to resolve dimension issues that can occur when applying Boolean or fancy indexing. We'll provide tips for effective troubleshooting, ensuring you can quickly identify and correct indexing errors. Finally, we'll share resources for further learning, helping you deepen your understanding of Numpy indexing and its applications.
As we conclude our course on efficient data manipulation with Numpy indexing, let's recap the key techniques we've covered. We've explored the fundamentals of array slicing, mastered Boolean and fancy indexing, and learned how to combine these techniques for advanced data manipulation. Efficient data manipulation is crucial in data science, enabling us to transform and analyze datasets with precision. We encourage you to practice these skills on real-world datasets to solidify your understanding. For continued learning, explore additional resources and case studies to further enhance your proficiency. Thank you for joining us on this journey, and we look forward to seeing how you apply these skills in your data science endeavors.